Thank you. For our next panel, we'll be venturing beyond Earth into the NEO destinations. We all know that this is, as the President has directed, a very critical future for the spaceflight community. But what exactly is this going to mean in the time frame that we're going to be developing in? This next panel will focus on both using the resources, the hazards, and how do we deal with the consequences of these objects. So to lead this panel, I'd like to introduce Dr. John Karcz, the moderator. He is from NASA Ames. He is a physicist and scientist with an interest in commercial space. So I'd like to introduce him. Thank you.
If I get the panel members to join me up here. I think that we have one of the more important and fun topics ahead of us this morning. We've been asked to discuss near-Earth objects and the opportunities they may present to us, the resources they may present to us, the hazards that they pose, and how do they fit into the broader human activity in space. We're going to try to keep the discussion pretty broad, to look at the links between, to think both about NEOs and the resources that they may pose for people living in space. Some people claim that some of those resources might be valuable down here. We can talk about that too. And we can talk about the link between those, what we do at NEOs and at the moon and at Mars and wherever else we might go down the line. We have a few people who are going to join the discussion this morning. One is Blair. He is a mining engineer and mineral economist at the Space Studies Institute. Brad Bailey, who is a senior scientist at the NASA Lunar Science Institute. David Morrison, who is the director of the Carl Sagan Center for Life in the Universe and is a senior scientist at the Lunar Science Institute. And we have Pete Warden, who is fearless leader of NASA Ames. And we're going to start with just a few comments from David Morrison to give us some background on near-Earth objects so that we all know what we're talking about here. And then we're going to try to move quickly into questions then so we can hear what you're interested in discussing. So we'll start with David.
Oh, wonderful. I'm going to give a lightning review so we're kind of all on the same page. I've been struck by the fact that a lot of our focus is going not just to near-Earth objects, but to small ones because there are so many more of them. And they are an unexplored area of the solar system. They are stepping stones to Mars. I like that phrase, stones on the way to Mars. They're obviously the objects most likely to collide with Earth, small ones, so they have that interest from planetary defense. We'll be talking about resources. And finally, they have interest. You see a lot of things about asteroids in the newspapers, the Congress, the administration, so they have suddenly become important. Next slide is just to mention that there was an official assignment of responsibility, mostly in the context of planetary defense, that was made after many years of wondering. You know, the astronomers say, well, if I find an object headed for the Earth, who do I call? Now we know who to call. We call NASA, and NASA calls John Holdren. Next. We have had the Space Guard survey looking for near-Earth asteroids for 12 years, and you can see the progress. We found nearly 10,000 of them. The focus was on those larger than 1 kilometer, and we're 90% complete there. At the smaller ones you get just when they're close to the Earth, the number shoots up constantly, but even though the absolute number seems large at nearly 10,000, the fractional coverage is very small, as shown in the next chart. This is discovery completeness. At the 300 and 1,000 meter diameters, it's nearly complete. 300 is maybe halfway. So we know quite a few half-kilometer sized objects. Then it, back please. Then it goes way down. only about 4% of the 100-meter objects, and we got down to the 30-meter, and it's completely negligible. So there are literally 1 million objects out there that might be interesting targets that have not yet been discovered, and the first priority for any move is to have a better survey, a deeper survey, and find the smaller objects. Next. Finding them and characterizing them. I'm struck by the fact that spacecraft characterization, basically determining size, shape, rotation, composition, internal structure, addresses exactly the same questions for each of these fields. From the point of view of science, clearly you want to know what they are and what their role has been in solar system history. From the point of view of defense, you cannot effectively defend against an object without knowing more about its physical properties, so you know if it hits it, what happens. From the point of view of resources, obviously, we need to know what these things are made of, and selecting human targets. Astronauts, although some would like to, are very unlikely to visit an object that hasn't been previously visited and characterized, and we know how many characterization missions like Ranger and Lunar Orbiter and Surveyor went to the moon before the first humans. Is there one more? Yeah, just one of many recent workshops dealing with near-Earth asteroids as human targets for the next foray into deep space. They're making a lot of progress, and this now is 6 months old, but it's frustrating how little we know. At this discussion, there was, well, yes, we certainly need an NEO survey, but we don't have the metrics. We don't even know whether it's best done from space or from the ground. We don't know what the knowledge requirements are for astronaut visits. We have not defined the requirements for these robotic precursor missions, what you measure or how many objects you go to. And frankly, we haven't yet decided what the role of humans will be on these first missions to near-Earth objects. All open questions, all focusing on small near-Earth asteroids. Thanks.
Thank you, David. So they told me that my job is moderator, but I'm going to start with an immoderate question. So various people have claimed that asteroids are boring. What do you think of that?
That's rubbish. No, I've heard that, and you know, supposedly the public is much more interested in the moon or Mars, and but I think as David suggested or discussed, I can't think of anything more exciting. The key point, I think, is that these are primordial objects. They're the building blocks of the solar system. That's pretty exciting. Second, they're worth $1 gazillion. That's a very technical term. That's the U.S. debt. You know, and there'll be a lot of discussion about that. And third, and maybe this is most important, they're a humongous threat. You know, that is, I think, pretty well understood now that at least the last major extinction event on Earth was caused by an asteroid strike. And we see strikes occurring all the time. Probably the most recent big one was the Tunguska strike early in the 20th century. So from all those perspectives, I think they're very exciting. And probably the most important thing is it really gets down to just practical matters. It's easier to get to an asteroid than any place else in the solar system other than Earth. The delta V, the amount of energy you need to get to them, is less than going to the lunar surface. I think somebody yesterday said you don't need to build a lunar lander. And it's a lot less than getting to the surface of Mars. So, and needless to say, NASA and the private sector and other countries just don't have the money to spend a lot. I know there's a lot of people that are worried about, well, the Chinese will get back to the moon before we do. Well, you know, my point is, so what? Been there, done that. People got the T-shirt. We're off into the solar system. We're on our way to Mars and beyond. So I I think they're pretty exciting. And finally, if somebody thinks they're boring, have they ever read the Rama series from Arthur C. Clarke? So you never know.
Well, it's a good question, and I think part of the answer is we don't know how interesting they are, at least as scientists, because we haven't been there. I mean, the fact is, if you only see a planet as a point of light in the sky, you don't know if it's interesting or not. And so getting there with robotic spacecraft first is going to be essential to teach us what we don't know and what we need to know. Give you one little comment on human missions. You know, we always talk about the footprint. Well, you're not going to do a footprint on a 100-meter asteroid. It's a microgravity environment. For astronauts there, it's more like maneuvering around the space station than standing on the moon. But there's an interesting little exercise. Well, you want to do something. Maybe you want to put a footprint on. So you put a boot sole on the end of a pole, and the astronaut sticks it in, you know, like branding. And then you say, well, does the astronaut need to be there? Or could she be in the mother spacecraft and have a very long pole or a robotic system to do it? Or could it be done from Earth with a robotic system? What is it that's implied by touching the asteroid or putting a footprint there? And that, to me, is a very interesting question, too. How interesting will it really be to us and to the public to go to a small object?
So as the token lunar scientist here, I was brought on to give a little bit more of the scientific perspective on why asteroids are interesting. And to be honest, asteroids and near-Earth objects and other primordial bodies are extremely interesting from the standpoint that there are certain scientific questions that just cannot be answered anywhere else. And one of those is, as was alluded to by David and Pete, was the origin of the solar system, how the evolution of the protoplanetary disk ultimately created planets, and ultimately we need to go figure out what these NEOs are made of. There are chondrules that are thought to be the original things that came out of the protoplanetary disk, and so they were then witness to all further processes that came about throughout the whole evolution of the protoplanetary disk. Some of the other things that are very interesting are, again, the chemical makeup of these. If you look at carbonaceous chondrites, you start to look at the high degree of volatiles associated with them. Some of them are measured up to 22% water. Some of them have a high degree of organic material in the form of amino acids. They found alanine and glycine. There are polycyclic aromatic hydrocarbons in there. And if we really want to understand the origin of life here on Earth, we need to discover how those mechanisms or how those elements were delivered to the surface of the Earth. And then finally, what I think is very interesting from an asteroid point of view and a future of human exploration point of view is, in order for an astronaut to go out beyond the protection of the magnetosphere of the Earth, they will receive a total lifetime dosage of radiation in approximately 6 months. Now, the closest, to my knowledge, NEO that we'd like to visit is going to take 9 months to get there. So we don't really know how to live and operate in long-term space exploration. And so asteroids are going to be the next logical target for us in terms of going to Mars and really understanding how to mitigate radiation effects.
The good news is asteroids are the only planetary body with their own sample return program. The bad news is that really large samples come in every once in a while, and they're very disruptive. Ask the dinosaurs about that one. We know a lot about asteroids because we got a lot of pieces of them. We just have a hard time mapping those pieces to the known set of what we see. Remote sensing is actually a really nice way to sort of offset that, because we, at least within the thin veneer of that surface layer, optically, there's the weathering is well understood, and the spectral patterns of these minerals are well understood. A certain Air Force general once told me about what happened when Severe's space-based infrared the early warning system, one of those spacecraft got turned around, and the sky was lit up with asteroids. We actually have capabilities right now in space, the assets to do a lot of pretty detailed mapping of what's out there. A lot higher resolution than what we have. We're just choosing not to use that right now to truly assess the hazard that's at hand. And you know, what excites me about asteroids is, I guess as you know, my training in mining engineering leads me to two primary conclusions about the cost of you know, acquiring the stuff that this microphone is made of, and much of this building is made of. Most of what we have in our human infrastructure is mined and processed and turned into things like buildings, and it abates things like weather and can contain atmospheres. And these are our future, you know, habitats. This is the future of the human race. The two primary cost factors in mining are excavation and fragmentation. If you have to go deep underground to get your resource, it's going to be expensive. And asteroids really have, it's like nature's gift in space to mining engineers. They're pre-fragmented and they're largely excavated and scattered about. So if you have a good camera and you can find what you're looking for, and there is some evidence of differentiation in some of the asteroid bodies. There's like a 2-kilometer sphere of stainless steel out there that Dennis Wingo likes to talk about, and John Lewis. And finding what you need to turn these things into you know, infrastructure and habitats for the future of humanity, Gerard O'Neill space colonies or Death Stars or whatever you want to make out of that. The resources are really there, and actually we have a lot of the technology today. What we really don't understand is where the markets might be going as you know, a function of the future. And I think that's mappable. John Lewis had an estimate that the population capacity of the inner solar system using the resources of the moon, Mars, and the asteroid belt is 100 trillion human beings, and it makes each one of us responsible for 10,000 offspring. So I guess we ought to get busy because we have a lot of populating of the universe to do here, or at least the solar system. That's just within our own solar system, by the way.
I know you know this, but let me remind the audience that a 2-kilometer diameter piece of stainless steel you better be careful with. We don't want it to come to the ground at 11 kilometers a second.
So maybe let's talk about resources a little bit. What do each of you think might be valuable resources? You know, both in the intermediate term and farther down the line.
Well, let me start. I mean, I think there's two categories of things. The first category is stuff we need to live in space. That if you're going to settle the solar system, and those are, you know, the stuff of life, volatiles, hydrocarbons, and so forth. And there are classes of asteroids that are very rich in those, that we know they're very rich, and we see them on the ground. The other one, of course, are materials that might be rare on Earth. You know, the one I found that recently is most interesting is people talk about platinum. You know, platinum as our other metals is a differentiated object. You know, it's the metal cores of planets. So there's not a lot near the surface of the Earth. You have to dig pretty deep, or there's small deposits. If you do find, which we know there are metal asteroids, then those are potentially very rich in platinum. Now, platinum is a key component of catalytic converters and other items. So, and we're running out of it. And at some point, when you start getting the cost of this stuff is tens of thousands of dollars per kilogram, then it begins to look interesting to, you know, rather than dig 2 kilometers down in our planet, which is very expensive and very dangerous, it might eventually be cheaper to get it from space. Now, so I think that we got to look at both of those. Now, there is, I reminded, there is a third one, which is just sort of interest value. You know, today you can sell pieces of meteorites if they're the right type for, you know, tens of thousands of dollars per gram in some cases. My suspicion is that there may be some sort of, I can imagine that, just like diamonds were sold, a century ago, is you have to have a diamond to be a proper wedding ring. If somebody could do the right PR, you say, well, you have to have a piece of a asteroid, or it's not a proper wedding. So that's one of the entrepreneurial things. So I leave it to you guys to figure out how to do that.
So I believe that, hello. I think that in terms of what is valuable associated with NEOs is I would prefer to think that we're going to colonize space for the long term. And in order to really create a sustainable habitat, we really need to focus in on the volatiles and where we can get water, where we can get organic compounds and stuff like that. And while recent missions to the moon, shameless plug for the moon and NLSI, there you go, David. I think that recent missions to the moon have shown that there is a hydrological cycle ongoing on the moon through Karcz and discovery of water on the permanently shadowed regions on the poles, and then M-Cube discovering water even at the lower latitudes. That data is starting to permeate into the NEO community to where people are starting to think about hydrological cycles on asteroids. And if we can start to figure out how that water was ultimately emplaced on the moon and consequently, therefore, on asteroids, we can then start to think about long-term sustainable habitats outside of our own gravity well.
I guess I would characterize resource and resource value as a function of markets. Who the customers are, and following on with Pete's point, which is that given current launch costs, thank goodness some NASA centers are trying to make a aggressive effort to lower the cost of launch and operations in space. But given current pricing, if there were an asteroid made of solid platinum, we couldn't afford to mine it and return the material here and make money right now. As infrastructure grows in space and as capabilities grow and as costs continue to drop, there will be a threshold that's crossed where that does become valuable. However, given current costs of access to space and putting things there, there's also a much larger impact of using materials that are in space for doing things in space. For instance, shielding for a Mars mission. If there were a way to, grab bags of regolith from any asteroid that happened to be optimally located in terms of the orbital mechanics, you could use that to offset a lot of the cosmic radiation. I've heard a couple of meters get you low enough back into the secondary radiation production regime that you might not cook your astronauts in the habitats or things that are beyond the Van Allen belts that protect us. So there are really simple things. I also have to agree that volatiles are very important for two reasons. One of them is life support, and the other is propellants. And those are, some of the early markets that I've modeled in some of the economic analysis that I've done. I'm, again, a mineral economist, and the reason I chose to study that discipline is to apply knowledge of economics derived from the mining industry to problems for space. I believe that, asteroids are ore bodies in space. That location is different, but the tools are identical with how valuations are done for things that are here. And really what that depends on is, market studies and market analysis. And if we don't know what the path of the evolution of markets, or put together a vision for what the path of the evolution of markets and how those markets, interplay or interface with each other and activate levers and tipping points that, for instance, a space volatile supply from asteroids or the moon would enable lower cost propellant depots, which enables lower cost orbital operations. And these things play together in synergistic ways. And I think that we have the skills and tools available to us now as a community to really begin to put more detail and more information behind some of these visions for space infrastructure, and call it markets, and call it business. That's really what we're, I think, starting to get into. It's a new era with that.
Just to add one perspective, I'm not an expert on ISRU, but think about how this is going to play out. What is the immediate imperative for understanding and sending missions to NEAs? It probably is the president's statement that we're going to send astronauts to one by 2025. Then there's the question of defense. If we carry out a deep survey and find hundreds of thousands of objects, you know, the bad news perhaps is we're likely to find several that at least are on possible collision courses. And then, while maybe probably most of them won't hit, that is a real imperative to protect the Earth. And probably those things are both going to happen before, in my opinion, before we are really trying to utilize NEAs. So we should think about how to combine the information, how the search that some people may feel is absolutely essential for protecting the Earth against asteroids can be turned around and use asteroids as our friends, not our enemies.
Well, so, you know, I think that actually leads in reasonably well to a question we have here from the audience. I might vary it a little bit. The question is, can you explain what the value of a human NEO mission, what value a human NEO mission can provide over a robotic mission to help us understand them and to advance the ability of humans to move beyond low Earth orbit? And, you know, I might ask you to also comment a bit on the interplay between humans and robotics out there.
Well, there's really, again, two answers to that. The first one is a philosophical one. You know, in the early 90s, I worked at the White House National Space Council and as a staff officer for the first Bush administration Moon Mars Initiative. And we tried to find a lot of reasons, you know, why we were doing this, why we're spending all this money. And we ended up not spending any money. But so we had a bunch of experts come in, and we came up with the usual, well, there's spin-offs and there's jobs and, you know, so on and so forth. And, you know, it kind of got to be the argument that kind of like the old Southern lawyer that's defending somebody in court accused of murder. And so he's wrapping up his discussion, and he said, well, my client couldn't have done this. You know, he was 500 miles away. Had no motive, and so on and so forth. And besides, he did it in self-defense. There's one too many excuses. So what we got finally was that the reason we are sending people to space is we are people. And that if we were robots, we'd send robots. But we're going there because we are expanding humanity. And I think it doesn't need much more justification than that. Now, that having been said, with the current level of technology, we find that telerobotically operated things, where there's a human able to operate something, is far more productive than a completely autonomous robot. The technology just isn't there. You know, we can see that on things like the Mars rovers. You know, you've got a 20-minute time delay, and to program that to do much, I mean, those things are moving at, you know, inches per day in many cases. Telerobotics is pretty sophisticated. In fact, we can do intercontinental surgery now. And so the point is if you really want to do an in-depth investigation, if you want to drill into an object or you find things that are surprising that you need to look at, that having the human there to telerobotically operate it, so it's sort of the human is it's hand and claw with the robot, that it's far more productive. Now, that could change decades into the future, but for now, I think that's one of the real values of humans.
Well, I agree, Pete, and I think that the fact is we're probably going to do humans to Mars also by telerobotics, perhaps initially at least from the moons of Mars before landing on the surface. So there's an important learning curve there. Whether this is interpreted...
Which, by the way, may be asteroids or may not
Yeah.
be.
The question I would ask, and I'm asking instead of answering, is how the public will perceive it. How the public would perceive an astronaut in a capsule 100 meters off the surface of this object running a rover, even though it's tremendously productive of information, how that will be perceived. And I don't know.
So I'd like to echo a little bit what Pete said, and I actually come from a microbiology background where we went down into submarine volcanoes to look at hydrothermal vents, and we did that both via submersible, and we also did it via robot from the surface. And I'll tell you that in the 8 hours that we were down, we actually got as much science done in the submersible, since we were there able to witness what was going on, as we did in 24 hours of around-the-clock operation from the surface. And the reason for that is we're able to look around, we're able to do we're much more effective at doing the science and locating abnormalities that we say, hey, look at that, that's interesting, let's go pick that up, rather than having a robot try to do that. Now, realistically, I don't think that we have the fundamental biological knowledge to send people to asteroids right now. I think that robots are the way to go until we can start really ramping up the biological research necessary to keep people alive and make sure that when the astronauts do finally get to wherever they're going, they're not just laying in their bunks with radiation sickness. And so I really think that the immediate future of NEO exploration is robotic.
I'm firmly convinced that had Spain had a robotics program 500 years ago, there would have been people who asked, or would have made the statement that, why wouldn't we send robots to North America?
So why do you think we should send them to, why should we send people to asteroids?
Well, I agree with Pete's comment.
All right.
Fundamentally, because we're human and we have that explorer gene, and a few of us are, I guess, when the deer population maxes out in a certain valley, a few of them get the courage to go over the mountain pass into the next valley, where they find, more green pastures, rather than overpopulation. It's built into the genetic mechanism, if you will.
So why don't we follow on this topic for a little bit and ask if each of you were on an early mission to an asteroid, what would you want to do? What would you do if you were there and you had access to whatever equipment you want on the other side and some radiation shielding? What would you do?
Well, it depends what kind of asteroid you're going to and what your mission is. I mean, if it's a commercial mission and you're interested in finding resources, then obviously you're going to be like a mining engineer or a mining or geology explorer that you're interested in doing assay. If you're there on a biology precursor to life mission, it's much different. You're going to look for chemical evidence of amino acids and other items. I think the first missions are going to be doing a little bit of everything. I mean, and it's very important to kind of figure out what kind of object we want to go to. I mean, you've got things that range from, maybe dead comets that probably have a lot of volatiles to metals. So, which makes asteroids very interesting, that you want more than one mission. One thing was mentioned, I think earlier there was some question in the previous talk about old people in NASA. Frankly, you also talked about radiation problems. Now, when you're my age, I'd be happy to go for 9 months and say, all right, it's a little radiation sickness is probably worth the chance of going to do that. And so, quite seriously, one of the things I think you're going to see more attention to is when we do these longer missions that might be more dangerous, is maybe selecting a different group of people than we did in the past.
Well, I'm too old to go.
No, you're not.
But what? I think the first thing on the...
Would you go if we...
Well, I never applied for the astronaut program when we were going to the moon. So I think it's a realistic self-evaluation there. But I think that the first mission, the astronauts had better take some really cool pictures of the Earth from a distance where it's no longer a blue marble, but a dot with this asteroid in the foreground. Things that will really be on the front page of the newspapers.
2 dots.
Yes. Yes. Yeah, here's our other dot.
I'd go. I'd go in a heartbeat. that's all I got.
Yeah, all right, good, that's enough.
I'd probably burrow in, set up camp, and you know, try to live off the land and sell what I could to you know, get wealthy, become the first trillionaire.
But what would you do early on? You know, you're there for the first
Furthermore,
time.
I'd probably send a letter to the Russian embassy, to the U.S. embassy, and to the United Nations saying, this is my property, back off.
All right, I like that. All right, so.
John, can I ask, we were talking a little bit about, you know, there's a lot of discussion about, you know, sending people to anywhere that's dangerous. So let me ask this audience, which is, you know, a lot of entrepreneurs and visionaries, that if you were going to go to an asteroid and I said, that's pretty dangerous, you maybe only got a 10% chance of coming back, how many would go? Good. 1%. Also interesting. So, no, I find that very interesting set of numbers, and I think that's an area of discussion, that people are willing to take big chances to go to new places and see new things.
So just to follow on that just a little bit, I think personally, you asked what we would do, and my clear interest lies along the realm of astrobiology, and really trying to focus on getting determining the orbit specifically associated with each of the NEOs can then allow you to deconvolve the history of the evolution of the solar system. You can start looking at the bombardment history within the inner solar system, the bombardment history of the Moon and Earth system, and really that will start to tell you a little bit about evolution. I already mentioned about the organic transport to the surface, and really I think there's just a lot that we just don't know about ourselves as a people, and truly understanding what the origin of life is and where we came from is something that is a question that we're always going to ask until we figure it out. So from that point of view, what I would want to do is astrobiological in nature.
Yeah, I might throw my 2 cents in on this one also, that I think that there's a set of things that initially look very mundane that might be valuable to do there. Just direct interaction with regolith, you know, have the ROV poke it with a stick, you know, try to move rocks around, understand the interaction between the behavior of the material, and do things that might be necessary or make it easier to do other resource extraction or deeper exploration of the rock. There may be things like that that really benefit from being there with your hand on a joystick and manipulating the object yourself.
Let me share a story with you from about a year ago, very shortly after President Obama first said we wanted to send humans to an asteroid, and I was at a meeting with some people from JSC, and I'm not sure what they said explicitly, but implicitly they were talking about astronauts walking on the surface. And I said, wait a minute, this is microgravity. You're not going to do this. This is going to be much more analogous to astronauts maneuvering around the space station, which incidentally isn't that much smaller than some of these asteroids. Their answer was simple. Yeah, but the space station has handholds.
Yeah, I guess, I mean, and that's really one of the thoughts. One of the first things we need to do is figure out how do we anchor to these things. You know, I mean, if they're piles of rubble, it's kind of hard to anchor to things. Now, if they're nice pieces of metal, you know, you bore into them. So I think one of the key research areas is that, you know, if you're going to interact with this thing, I mean, the Japanese found with the Hayabusa probe that, you know, they were going to try to grab a sample. Now, fortunately, they got about a dozen grains, right? But, you know, that's a very hard problem. We don't know how to do it.
A wise man once told me that that if you're operating in the gravity well of an asteroid, if you pass gas, you'll achieve escape velocity. So, you know, it's
That's the quote for the conference, I think.
And so, like David said, it's very unclear how we're going to do any type of surface operations on asteroids or NEOs, and that's one of the big things that we need to figure out as we move forward.
I love talking about the technology, and you know, there's a variety of things that I've become aware of over the last few years. Richard Karcz used to propose throwing a net around an asteroid, and those can be done for, I think, relatively low mass, and it gives you lots of things to hold on to, lots of places to hold on to. There's also, you know, I think some new work that's being done around electrodynamics or, you know, magnetic forces. Larry Taylor has hypothesized, or I think he's got some evidence for nanophase iron particles in the lunar soil. And if you've ever seen Larry's demo with some Apollo 17 lunar soil that he has and a magnet, it's a very strong coupling. So there may be ways to use magnetic fields to increase the reaction mass, effective reaction mass. The magnetic boot idea that, you know, used to be in sci-fi, you know, for walking around on your space station that was presumably made of iron, not aluminum, may actually have some merit for asteroids if you're looking for that. I think there's a lot of good solutions. Certainly the mining industry is very familiar with all kinds of anchoring technologies, from rock bolts to stabilizing soil masses to throwing in geofabrics and, you know, creating, you know, things that you can hold on to that, or keep walls from falling in on your operations or whatever else. So I believe we have a lot of good solutions there in terms of the technologies that are available today.
How about we talk for a little bit about some of the connections between NEOs and broader activity, and actually come back for just a moment and as we think about how they might affect commercial activity, how they might interplay with commercial activity down the line. Just talk about what sort of, how we use at NASA, you know, how commercial capabilities affect what we do at Asteroids right now. You know, in the context of our scientific missions that we do. I mean, I think there are a lot of people here who may not be familiar with what a competitively selected mission looks like and how those teams form and how we find the capabilities we want to use for those missions.
Well, one thing that I think is clear is it will need a public, like you, interest to get us off the dime. We've been trying for several years to get started with a space-based survey, and it never makes the grade. It's probably going to happen because the astronauts need it or because we're worried about planetary defense. But there's got to be some sort of public demand, and I don't mean everybody, I mean informed public like you, or we're not going to do it because these are at least initially going to be NASA responsibilities, and they're in competition with a lot of other proposals, especially in the science area.
Yeah, I want to go back to something Brad said. You know, you're talking about how to generate public interest. I mean, science is obviously one, and you know, through science proposals and so forth. But the key point is that, you know, there's several motivations that you find that people will do things for. I mean, one is greed, one is fear, one is curiosity, and one is, you know, creating a monument to yourself.
They all apply?
They all apply. But then let me go back to the greed thing, that we really do need to define that if you go to this asteroid, do you own it? Now, clearly the Outer Space Treaty says that governments can't own them, but it is silent about the human ownership or individual ownership. So, you know, or do you have, you know, the rights to use the resources? And I think that's one of the things that we need to get to. I know it's kind of the U.S. position that the Outer Space Treaty doesn't apply to individuals, at least using things, but that's not been explicitly stated. And so I think one of the first things is we need to define, if you go to this thing, do you own the rights to something, or how extensive rights? Do you own it for 100 years? Those kind of questions.
My focus isn't on convincing the public, it's on convincing investors. And you know what, I'm not ready to state that there's a business case there yet. So, you know, I think we have some things that need to happen. You know, right now, we're learning more and more about the resource. You know, we keep sending space missions to asteroids, and I hope we do more. And I hope some of these CubeSats can begin to, you know, give us more information about asteroids. I would love to see the number of asteroid photographs or the spectral data exponentiate at this point, I think have a pretty good handle on the technologies that are required for mining and mineral processing. There is an awful lot of sophistication in extractive metallurgy these days in the world. And there's a lot of good chemists and metallurgists working on clever ways to get more out of less with better or higher refining values than more nines than ever in terms of purity. And those processes, I think, with a simple understanding of microgravity physics, many of those can be mapped into space. The big uncertainty right now is in markets. Who are the customers?
Well, all right.
Yeah, the other uncertainty, I just remind you again, is finding them. If we don't do a really powerful, comprehensive survey, we'll never find out what the options are.
Oh.
What's the current level of NASA funding for NEO work, and how does that compare with its importance in other areas of funding?
Well, the survey is $4.5 million a year. And there was an effort to increase it to 16 in the president's budget, but we don't need to talk about the status of budgets right now. Now, in addition, there are missions, and the NASA Science Mission Directorate has just selected a big, beautiful mission called OSIRIS-REx in the hundreds of millions of dollars category to go to one asteroid. So it pops up in various places, but there's not an asteroid office. There's not an office assigned the task of protecting the Earth from asteroids. We're still kind of on square one.
In other words, it's tiny.
Pardon me?
Funding is tiny.
Yes.
But a big effort is done through the amateur astronomy world, and that's where most of the real work on asteroids and finding them is done.
Gil, how about we take one or two more questions directly from the audience? Yeah.
Yes, there's the need to construct an engineering database so that expeditions that return. There's a need to create an engineering database to design missions that return tens of thousands of tons of material, because this is somewhat the economic breakpoint if you're going to make human habitats in, say, Earth orbit or someplace from asteroidal material. We have data, meteorites, meteor tracks, data, the return emissions from asteroids, to actually start building models of how the regolith exists, making stimulant regolith, surveying what the high, small delta V asteroids are. This all needs to be put together in some common international database in order for practical engineering of these missions to start. So how do you see this institutionally taking place?
Well, as David said, we've had trouble getting NASA's budget up. I'm actually quite encouraged with the private sector. I mean, there's a lot of investment in the survey instruments like the Large Synoptic Survey Telescope and so forth. So the Minor Planet Center is largely privately funded, that tracks these things. There needs to be a lot more in it. So one of the interesting things, the theme of this conference is, don't look to the government to do everything, because, we won't. See, I think you had some questions in the back there.
Just last week, there was an article in the LA Times about a newly discovered Trojan asteroid that had kind of an odd elliptical orbit because, it basically got out of the sun shadow far enough that we could find it. Any comments on missions or plans to look for things like that we can't presently detect because they're sunward?
Well, yeah, that's a very neat discovery, and there's been a lot of email back and forth among the dynamics people who say that the actual Trojan point, 60 degrees before and after the Earth's orbit, is a very weak gravitational well, unlike Jupiter's Trojans, and that probably this is something that just wandered in and may stay there for a few hundred years or a couple of millennia and will wander out again. So it's probably not substantially different from the other objects that come by. For the ones that have really Earth-like orbits, and there are a few, essentially at 1 year period, my colleague Al Harris keeps pointing out, yeah, and when you go there, it may be painted white and have lettering on it.
Yeah, I think that's a good question about missions to them. One of the key things is that, you know, in the past, missions have cost, you know, a good bit of $1 billion. One of the things, in particular, this center is trying to focus on is, can we do low-cost rendezvous missions with these things? And I think the technology is beginning to get there. In fact, one of the more important initiatives, and I hope it gets funded, is that in the Office of Chief Technologist, they have something called the Franklin Edison program, which I'm proud to say is managed out of here. But we're looking at something called planetary hitchhiker, where we can put a secondary payload on for example, a mission that might go to geosynchronous, and then you can get enough delta V that it could actually go rendezvous with an asteroid, and we think those costs could be a few tens of millions. Once that happens, then these type of objects, these ones that are in 1 year orbits or potentially Trojan orbits, become quite feasible to do with the kind of resources you can get. I mean, if it cost $500 million or $1 billion, like the New Frontiers mission, you know, we're not going to have very many of them. And, you know, you have to be very careful of what you pick in the scientific justification. But if it's a few tens of millions, you know, it's one of those things to say, hey, let's go take a look at it. And we're getting there. So I think that's going to happen.
Actually, I might ask just something a little bit broader, too.
Oh, I just wanted to comment about the fact that there are other missions out there that may not be specifically targeting NEOs and asteroids, but have done asteroid work on the way, such as Cassini. It discovered a captured asteroid around Saturn, and then we have New Horizons, which is off to Pluto, and on cruise phase, it's actually going to be looking for trans-Neptunian objects and stuff like that. So with regards to missions, there are other ways of looking at these primitive bodies.
It's a good point. I just note that most of that is big asteroids, main belt asteroids. The NEOs are just too damn little to be easily picked up without a dedicated mission to go there and rendezvous.
So, slightly expanding on that question, are there specific surveys, say, or specific near-term tasks that we should be thinking about that are both beneficial, robotic missions to start with, or surveys that are beneficial to commercial development of these objects and to our scientific interests? I mean, what are the near-term things we want to be doing?
Well, there's been quite an argument over the last few decades. Can you do it all from the ground or not? And you can do a lot of it from the ground, and indeed there are two major programs. One, as I mentioned, is the Large Synoptic Survey Telescope, which is you know, significantly privately funded, but it won't begin operations, I think, for another 6-8 years. The other one is a Pan-STARRS, which was a Department of Defense funded, really, space surveillance set of telescopes in Hawaii. The first one of those is now operating, but the question is, can they do the job? And we mentioned the Trojan asteroid. It's very hard to see things that are in almost Earth-like orbits, and particularly if they're interior to the Earth's orbit. And so it's been proposed that we have a space-based survey. Generally, you want something interior to the Earth's orbit because you're trying to look at stuff that's going to cross the Earth's orbit, potentially hazardous. And the proposals are to put a modest-sized telescope in Venus orbit, for example. And I think those are the class of missions that have been discussed, but they're expensive. That's a good bit. It's about $500 million to do those, at least the way we do them today. So, you know, I think there's a lot of room for sort of continuing to develop that. Again, I'm hoping some of these smaller missions might be able to bite off pieces of that.
But the systems you're talking about are basically for survey, which is
That's right.
really important, but it doesn't get you there.
Right, and so then you follow with a affordable mission, so you can go to dozens of asteroids because, we already know that there are incredibly different characters of these things, and as David said, some of them are going to have United States painted on the side of them, and that look like they're in kind of Earth orbits since we put them there a few decades ago.
So we've just got a few questions from the audience, and I think one of these is great. What work is currently being done with regard to robotics in both NASA and the private sector to prepare for visits to NEOs? So what sort of relevant robotics research is going on directed at that?
Well, there's sort of two. There's robotic missions, which we refer to any sort of mission that doesn't carry humans. And there's a lot of work. There's, since the president said we're going to go to asteroids next and that they're human targets, there is a significant amount of discussion and design work on all the way to from fairly large missions down to fairly small missions. Unfortunately, none of those are funded right now, other than the studies. But there is, there was mentioned the science missions. There is the New Frontiers mission, the OSIRIS-REx, so that's going to go forward. And there are potentially other science missions that are in analysis. Some of them including sample return, which is very important. The other class of robotics are things that actually, what we think of as a robot that actually interacts with things. In that case, there are not yet missions, but there's a substantial technology effort at NASA to look at, what kind of robots. How do you put the autonomy in this robot that you can send it there, that, if it's 15, 20, 30 minutes light travel time, that it can actually do some things more efficiently. And then finally, the question was on private sector missions. I'm aware of at least, 4 or 5 groups that are beginning to look at private missions to asteroids. Most of them, are motivated by long-term interest in potentially mining, although there's also some scientific interest and some interest in protecting the planet. Again, with private missions, I think one of the key things is if you go and show up at an asteroid, do you own it? We don't know.
So I would just have a question that kind of follows up on that for my fellow panelists. So here at Ames, we had the Karcz mission, which was low cost and on budget and was really effective in what it did. Do you think that it's realistic for us to do an Karcz style mission to where we impact the surface of an asteroid? And I think that comes about from a scientific point of view, but also can be looked at from a planetary protection point of view in terms of moving them around with small masses and
right on, right on. The most exciting mission that I have heard suggested originally was from Europe called Don Quixote. It's just what you say, but it's not enough to hit it. You need another spacecraft there to watch what happens and see what the hole looks like. So what you need is 2 spacecraft, one in rendezvous and then another hitting at high velocity, which means 2 different launches, which means it's beautifully set up for collaboration between countries or including commercial partners. It's just all you have to do is argue about which one has the science instruments and which one does the bombing run.
There's a perspective, I think, of, well, I guess an analogy I'd like to draw with asteroids, which actually present that hazard/resource duality. They have certain asteroids can show both of those faces. And the analogy is actually with flooding. The 100-year flood will wash through certain valleys and destroy infrastructure and farms and things like that. And right now there's a U.S. government program, with the Army Corps of Engineers to go in and build dams and turn that hazard into a resource. It turns it into a reservoir that can benefit recreation and provide steady supply of water for that very same community. And I think with asteroids, we're looking at an opportunity to do that public-private partnership, that win-win scenario that not only mitigates or reduces the level of hazard, but at the same time can leave something behind that could benefit future generations in terms of the resource side, the upside of those very same objects.
Yeah, let me address the question about L-Cross. For those of you that aren't familiar with it, I think most of you probably are, it was a low-cost add-on mission to the Lunar Reconnaissance Orbiter where we had extra payload, and there was a competition across NASA. And there was a secondary payload where we directed the upper stage into lunar polar crater to impact and do an assay, and it worked very well. There's a long story about the bombing part of it, which I'm guilty of. I already. So, we have proposed additional N-Cross, P-Cross, A-Cross missions. They haven't been selected. One of the problems is, and this is a difficulty, is that the L-Cross mission was interesting because it was a exploration mission, which has different criteria, and it's involved more in developing technology and actually takes more risk. It was what NASA calls a Class D mission, which meant that it had single string. In fact, we almost lost the satellite on the way to the moon. But it requires more risk. Most missions that NASA does are science missions, and so they are competed, and one of the things is, have you done this before? And interestingly enough, we said, well, we did it with L-Cross, and they said, well, that wasn't a science mission, so you really didn't do it. And honest to God, that was one of the responses we got. So there is a dilemma here, and just as a plug, the new office, the chief technologist, intends to do these kind of missions, and we hope that Congress gets close to, or somewhere close to, the president's request on that, because I think unless we have these high-risk, high-payoff technology missions, we're not going to be able to move forward very rapidly. So this is a plug that if you got any influence, or you know a congressman or senator, or have pictures of them in a compromising position, please use them now.
All right, so for the last several minutes, let's go back to the relationship between human activity and people at asteroids, and how they relate to our future. And how can we use, one of NASA's jobs is to promote and encourage the fullest commercial use of space. So how can we organize missions to NEOs? What sorts of things might we do as we develop missions to NEOs that are actually beneficial, that facilitate commercial activity to use the resources or to undertake further activity farther out?
Frankly, I'd like to hear what the audience questions are. I think you ought to see if the audience has any additional questions.
Are there more out there? Yep.
Thanks. David, first thing, I disagree with you completely. You have to go. We need someone with your personality and storytelling ability, because frankly, I think the biggest impediment to an NEO mission is the PR nightmare that it has, because people can't walk outside and see the moon or even point to a light that says Mars. We don't even know where we're going, and it's really difficult to get public involvement when there isn't a good story behind there, and you tell great stories. So my comment and question was, about a year ago, I somehow wangled an invitation to the official NASA workshop on NEOs. Brad, you were there. I don't remember, Pete, if you were there. Very strange for a commercial space lawyer to be invited to that party, sort of the automatic skunk picnic. The thing I was really struck by, however,
I think that was the one I was at via a robot.
Yeah, yes, you were. That's right. That's right. Yeah. I was really struck by the fact that they had breakout sessions, and they came back, and the breakout session on doing the mapping and doing the survey came back with the Venus, outward-looking satellite, and of course, it instantly became a $1 billion mission with all the bells and whistles, and everybody got very excited about it. Well, the commercial space guy said, wait a second, I know people who can do that for a tenth of that cost, or at least half of that cost. we're at the Space Frontier Foundation conference. We're commercial guys. Ames is really sort of the commercial arm of NASA when you face it. But do you think that Ames and the commercial guys stand a chance against the rest of NASA, which, no matter what you hand them, they will fill that budget, to the max and more?
You must be talking about a center to the south of us, another one to the east of us. This is why the Office of Chief Technologist programs are so important, because they are oriented towards doing things differently and finding ways to do things affordably. I'm, hoping and praying and begging that those things get funded. Unfortunately, so far there's, at least there's some money in the House mark, but it's not enough to do these missions. But I'm convinced, yes, you can do these survey missions for probably, in the Explorer class amount, but they're risky, and you may have to fund a couple of them, but that's a paradigm shift, and it's hard. I mean, changing things is hard. We're going to keep pushing.
Got a really important question here. Jonathan.
I grew up with the space program, and when I was growing up and read science fiction stories, I would read about people going to Mars and opening colonies on Mars. I never read about people going to asteroids. I've spoken in the last 20 years to I don't know how many tens of thousands of Americans, and often the question is, when are we going to go to Mars? Not once have I had any American say, when are we going to go to an asteroid? Now, the previous administration was going to go back to the moon as a means to an end, not as an end. So exactly what benefit will we gain towards going to Mars and opening a permanent outpost in space by going to an asteroid?
Good question, except you're wrong. There was
one American I can remember who was interested in going to the asteroids.
Yeah, I remember this series about, Rendezvous with Rama and so on. Did you not read those? That was a fairly famous
There was
author.
some guy from Princeton, too, who was into it.
And that talked about space colonies using the resources from asteroids. So maybe you read different books than I did. So, I think asteroids are very exciting. They are in many books and discussions about as being the stuff that we can actually engineer in space to do space colonies. Now, that having been said, the asteroids make an ideal stepping stone to Mars, and I'm convinced that, I think as you are, that probably in the next century that the most likely place to settle is the Martian surface. But we need to do a lot of stepping stones to get there. We don't know how to survive in long periods in space. Asteroids make an excellent intermediate destination. They are cheaper than going to the moon. We can check out those technologies. They have resources that can help us potentially get there in terms of we've talked a lot in these conferences about fuel depots. The volatiles on them could potentially be a source of fuel depot. And the most interesting thing I think was alluded to here was that, as we do these stepping stones, the last asteroid you go to before you get to the Martian surface is Phobos and Deimos. And that is beginning to be the focus of this agency now. There are workshops and so forth that before you go to Phobos and Deimos, you're going to want to do a few test cases. In fact, I would say we are not going to the Martian surface until we go to Phobos and Deimos. And I'll give you one of the most interesting, I think, and likely reasons for that. There is some evidence, it's arguable, that there is extant life somewhere on Mars. It's probably deep underground. Whenever you mix two different forms of life, usually one kills the other. Now, so that tells me that, you say, well, there might be microbial life or some life on Mars, that, and this has a bipartisan problem. If you're a conservative, you're worrying about it killing us. If you're a liberal, you're worrying about us killing it. So I think we're going to fully explore Mars, including drilling, before we go there. The ideal place to do that from are those moons, particularly Phobos, because it's fairly close. The light travel time is a fraction of a second. It provides the shielding material you need for radiation protection. And by the way, Phobos, from all the pictures I've seen, seems to be littered with Martian material. And it's from asteroid strikes and so forth on the Martian surface. So that I'm convinced the path to Mars, and I think the agency is beginning to be convinced, is via these asteroids as stepping stones. So they are not ends of themselves, although there are, as I said, there are a lot of science fiction books that I read that talked about, you know, colonies on asteroids, hollowed out asteroids, all sorts of other things. So, you know, again, I just absolutely disagree that that asteroids are not been in the mindset.
Yeah, I might make a comment along those lines too. I think there are a lot of people, a tremendous number of people, who do want to go to Mars. And as somebody who's interested in developing the asteroids, I think that's great. They're potential customers. I want to sell them propellant and whatever else they need to make their trip.
Furthermore, there's potentially asteroids that are fairly close to cyclar orbits. And if you can hitch a ride to Mars or most of the way there and burrow underground and do it safely, it ameliorates a lot of the current radiation risk. I think there's a lot of subtleties that can be explored in these kinds of architectures. Another one is in terms of, you know, stepping stones, propellant depots. I see these things, I see settlement and colonization as economic behavior, and the support systems and the infrastructure as economic systems. And you know, there are arguments that can be made for putting propellant depots on Phobos or Deimos and maybe some of the asteroids in between.
Let me add, I mean, it's really part of history as well. You know, a half millennium ago, the age of discovery, if it wasn't for islands, you know, most of these great voyages would not have happened. Magellan, Columbus, and so forth, they went to islands before they went to the mainland of a new continent. And indeed, islands became the thing that enabled a lot of these things. And I think we should look at the asteroids as islands on the way to Mars.
Maybe one last quick question here.
Apophis is on its way towards Earth right now. Are there any current missions? The asteroid Apophis is on its way to Earth right now. Are there any current missions to rendezvous with that and potentially capture it?
As a matter of fact, the guy sitting next to me was the PI on a proposal to go do that. Unfortunately, it wasn't selected because it was considered too risky, and we weren't considered competent.
I'd like to point out something about Apophis, if I can, which is my understanding is that it's an LL chondrite. Is that right, Dave? Is Apophis an LL chondrite?
I think so. It's certainly an ordinary chondrite.
Okay. I read something that suggested that it was an LL chondrite, and a couple years ago gave a presentation here on what its valuation might be as a result of that. If that's true, then the universe has conspired with a very interesting coincidence, which is that LL chondrites are actually enhanced in platinum group metals. Apophis may be filled with platinum.
Apophis is a neat object. You probably know it. On Friday, April 13th, 2029, it will come inside the geosynchronous orbit level, and so it'll be a lot of studies of Apophis.
One of the interesting things about Apophis is it's a so-called keyhole object, which means that although it's not going to hit in 2029, if it comes, you know, hits one of a number of small keyholes that are only like a half kilometer or so across, it'll come back and hit in its next impact. Now, it's only one part in 10 to the 5th or 10 to the 6th that it would hit, but it's still a worry. So one of the things you have to consider about fiddling around with Apophis is that supposing we go do something and rendezvous it and just nudge it enough to put it into the keyhole, that's sort of a bad thing to do. So we would probably go to something else before we go to Apophis to sort of test out our ability. You know, you say, damn, we screwed that one up really bad.
It's a pretty big insurance premium.
Yeah, you touch it, you own it, right?
Well, on that note, I'd like to thank the panel. I think this is a fun discussion, and I'll pass it on to our hosts here.
Thank you again. We are now entering a half-hour networking break. I would like to make two really quick announcements before we leave. Gala tickets, if you had purchased them, are now currently available at the registration desk. You may pick them up all day today. And additionally, there's 3 tickets currently available for sale. So if you have not purchased a ticket and you would like to purchase a ticket for the gala, they are available. So thank you. at the registration.
Well, you didn't disappoint at all. I finally saw somebody else who was interested in looking at the asteroids. Somebody with a reputation. Yeah, I wrote a paper in the 90s called Asteroid. Like very large numbers of extremely small asteroids. It was a kind of a bullshit paper, but it had the same idea. You're going to try to use solar sails and stuff that's not right. Who waves are against that? I have a question. This actually, people talk about if you're going to do a survey just for some reason they're in love with putting them in. And I cannot see any.
I wanna dance on the ceiling. I wanna dance on the ceiling. I wanna dance on the ceiling. I wanna dance on the ceiling with you. I wanna dance on the ceiling. I wanna dance on the ceiling. I wanna dance on the ceiling. I wanna dance on the ceiling with you. Kick off your shoes and dance in the sky. Stand back and watch the full earth rise. Dance like a flame in free fall. We won't weigh nothing at all. It's getting crowded here, the air's getting bad. Noisy politics are making me mad. I want some distance, wanna see the sky. Come on, baby, let's fly. We can fly all night and never come down. Leap tall buildings in a single bound. Dance in space like I know we could do. I wanna dance on the ceiling with you. I wanna dance on the ceiling. I wanna dance on the ceiling. I wanna dance on the ceiling. I wanna dance on the ceiling with you. Oh, yeah. If I could take the very next flight to a big space station floating high in the night, turn off the gravity and let us through. I wanna dance on the ceiling with you. We can fly all night and never come down. Deep tall buildings in a single bound. Dance in space like I know we could do. I wanna dance on the ceiling with you. I wanna dance on the ceiling. Dance on the ceiling. I wanna dance on the ceiling. Dance on the ceiling. I wanna dance on the ceiling. Oh yeah, I wanna dance on the ceiling with you. And in your eyes, there's something there that you can't disguise. We could swear love never dies. Let me fly my rocket right into your sky. Dance on the ceiling. I wanna dance on the ceiling. I wanna dance on the ceiling. Wanna dance on the ceiling with you. I wanna dance on the ceiling. Oh yeah. Get up off the floor. I wanna dance on the ceiling with you. Yeah, yeah. Then we're in free fall. Stars are shining. I wanna dance on the ceiling. I wanna dance on the ceiling with you. I wanna dance on the ceiling. I wanna dance on the ceiling. I wanna dance on the ceiling. I wanna dance on the ceiling with you. I wanna dance on the ceiling. I wanna dance on the ceiling. I wanna dance on the ceiling. I wanna dance on the ceiling with you. Kick off your shoes and dance in the sky. Stand back and watch the full earth rise. Dance like a flame in free fall. We won't weigh nothing at all. It's getting crowded here, the air's getting bad. Noisy politics are making me mad. I want some distance, wanna see the sky. Come on, baby, let's fly. We can fly all night and never come down. ceiling. I wanna dance on the ceiling with you. Oh yeah. If I could take the very next flight to a big space.
Prometheus, they say, brought God's fire down to man, and we've caught it, tamed it, trained it since our history began. Now we're going back to heaven just to look him in the eye, and there's a thunder across the land and a fire in the sky. Gagarin was the first back in 1961, when, like Icarus undaunted, he climbed to reach the sun. And he knew he might not make it, for it's never hard to die. But he lifted off the pad and wrote a fire in the sky. Yet a higher goal was calling, and we vowed to reach it soon. And we gave ourselves a decade to put fire on the moon. And Apollo told the world, we can do it if we try. And there was one small step and a fire in the sky. I dreamed last night of a little boy's first space flight. Turned into me, watching a black and white TV. There was a fire in the sky. I'll remember until I die. A fire in the sky. A fire in the sky. Then 2 decades from Gagarin, 20 years to the day, came a shuttle named Columbia to open up the way. And they said she's just a truck, but she's a truck that's aiming high. See her big jets burn and see her fire in the sky. Yet the gods do not give lightly of the powers they have made. And with Challenger and 7, once again the price is paid. Though a nation watch her falling, yet a world could only cry as they pass from us to glory, riding fire in the sky. Now the rest is up to us, and there's a future to be won. We must turn our faces outward, we will do what must be done. For no cradle lasts forever, every bird must learn to fly. And we're going to the stars, see our fire in the sky. Yes, we're going to the stars. Prometheus, they say, brought God's fire down to man, and we've caught it, tamed it, trained it since our history began. Now we're going back to heaven just to look him in the eye. And there's a thunder across the land and a fire in the sky. Gagarin was the first back in 1961, when, like Icarus undaunted, he climbed to reach the sun. And he knew he might not make it, for it's never hard to die. But he lifted off the pad and wrote a fire in the sky. Yet a higher goal was calling, and we vowed to reach it soon. And we gave ourselves a decade to put fire on the moon. And Apollo told the world we can do it if we try. And there was one small step and a fire in the sky. I dreamed last night of a little boy's first space flight.
I went down to the park just to fill up the day. I saw folks playing frisbee and catching some rays, and I felt a bit down when it got to the day's end, wishing that there could be more to my weekend. When out of the blue came a dog with his master, a perfect little terrier, white alabaster, with a glint in his eye and a confidence in his gait. Even when lifting his right leg to urinate, he seemed to say he was somehow superior. And me, I was thinking, this dog seems familiar. I stared at the hound, and then that's when it came to me, bringing back memories of this doggie's fame to me. This dog was not an irregular rover. This was the dog they made all the fuss over. Who would have thought I'd cross paths on this Sunday in June with the first dog to walk on the moon? You see, this dog somehow got all this attention. Even his master got less of a mention. When they opened up space travel for the civilians, his master, a playboy, had spent several millions to go to the moon. And to make it all merrier, he had decided that he'd take his terrier. The talk shows and newspapers ate up the story. You'd see this white pup on the tube in his glory. The dog's popularity would never falter. He even got interviewed by Barbara Walters. They covered the training and all preparations, and it seemed like we all held our breath as a nation. The day of the liftoff for this little pet, and later the image we'll never forget. That first step for canines in his little doggy spacesuit. For the first dog to walk on the moon. And when I was young, I had my dreams of greatness, of flying in rockets in space, being weightless. I dreamed I could be like some star of space travel, but many years later my dreams would unravel. I guess I just wasn't a good enough student. I made some life choices that weren't so prudent. I work on the phones now in customer service, telling my callers, "Hi, Bob, at your service." I'm fielding complaints at this 800 number. What I do for money just couldn't be dumber. My company makes things like hair dye for men. I hear the same questions again and again. Things like, Is it okay to use this on my eyebrows? When it says on the box, not for use on your eyebrows, and it sure doesn't seem I'll do anything great all that soon. Like this dog who has been to the moon. And God, I don't know if you're somewhere out there, but if you are listening, it's truly unfair. I look at this dog and I see he has knowledge like nothing I learned in community college. This dog has seen worlds that I never will access, and he won't have to struggle with failure or taxes. This is a dog that has so much I lack. This is a dog who has been there and back. And God, I don't know if there's a reincarnation, but if you can help me in this situation, there's just one thing that I hope you can do for me. Maybe next time you can really come through for me in my next life, 'cause I know this one shot. In my next life, make me something I'm not, what I'm asking to be, as I pray to you under these stars. Is the first dog to touch down on Mars. I went down to the park just to fill up the day. I saw folks playing frisbee and catching some rays, and I felt a bit down when it got to the day's end, wishing that there could be more to my weekend, when out of the blue came a dog with his master, a perfect little terrier, white alabaster, with a glint in his eye and a confidence in his gait. Even when lifting his right leg to urinate, he seemed to say he was somehow superior. And me, I was thinking, this dog seems familiar. I stared at the hound, and then that's when it came to me, bringing back memories of this doggie's fame to me. This dog was not an irregular rover. This was the dog they made all the fuss over. Who would have thought I'd cross paths on this Sunday in June with the first dog to walk on the moon? You see, this dog somehow got all this attention. Even his master got less of a mention. When they opened up space travel for the civilians, his master, a playboy, had spent several millions to go to the moon. And to make it all merrier, he had decided that he'd take his terrier. The talk shows and newspapers ate up the story. You'd see this white pup on the tube in his glory. The dog's popularity would never falter. He even got interviewed by Barbara Walters. They covered the training and all preparations, and it seemed like we all held our breath as a nation. The day of the liftoff for this little pet, and later the image we'll never forget. That first step for canines in his little doggy spacesuit. For the first dog to walk on the moon. And when I was young, I had my dreams of greatness, of flying in rockets in space, being weightless. I dreamed I could be like some star of space travel, but many years later my dreams would unravel. I guess I just wasn't a good enough student. I made some life choices that weren't so prudent. I work on the phones now in customer service, telling my callers, "Hi, Bob, at your service." I'm fielding complaints at this 800 number. What I do for money just couldn't be dumber. My company makes things like hair dye for men. I hear the same questions again and again. Things like, is it okay to use this on my eyebrows? When it says on the box, not for use on your eyebrows. And it sure doesn't seem I'll do anything great all that soon. Like this dog who has been to the moon. And God, I don't know if you're somewhere out there, but if you are listening, it's truly unfair. I look at this dog and I see he has knowledge like nothing I learned in community college. This dog has seen worlds that I never will access, and he won't have to struggle with failure or taxes. This is a dog that has so much I lack. This is a dog who has been there and back. And God,
worlds calling out to worlds, while we on Earth are alive at the critical moment when we first decide to listen. Our species has discovered a way to communicate through the dark, to transcend immense distances. No means of communication is faster or reaches out farther. It's called radio. We are now on an unprecedented scale, listening for radio signals from possible other civilizations in the depths of space. This quest is called the Search for Extraterrestrial Intelligence, SETI, pronounced SETI. Let me describe how far we've come. The first SETI program was carried out by Frank Drake. His great achievement was to show that modern technology is fully able to listen for signals from hypothetical civilizations on the planet. The technology for detection has been getting cheaper, the sensitivity keeps improving, the scientific respectability of SETI has continued to grow, but our fear of the dark rebels. The idea of alien beings troubles us. We conjure up objections. It's too expensive, some of us say. But in its fullest modern technological expression, it costs less than one attack helicopter a year. We'll never understand what they're saying, some of us say. But because the message is transmitted by radio, we and they